Hello everyone, welcome to the presentation of my deep learning project, Handwritten Character Recognition. As a part of this project, I intend to build a deep learning model to predict handwritten characters from an image. The model will be trained on extended MNIST dataset. This has a large set of handwritten characters that include uppercase and lowercase letters as well as numerals. These are only English letters. We would be using Python's neural net API keras with TensorFlow as the backend. Here is the software and the hardware specification. Python 3.7 will be the primary programming language. Keras API with TensorFlow backend will be utilized as part of the neural network package. Anaconda and Jupyter Notebook are used to execute the program. Matplotlib, OpenCV, Panda and NumPy packages are also utilized. As far as hardware is concerned, all the models are trained on my Mac OS, which has 16 GB RAM and 128 GB hard disk drive. Data description. So extended MNIST is a set of handwritten English characters, both upper and lower cases, and digits from NIST group or website. So this data set is hosted at Kaggle in the format that I want, which is the CSV format. It has, I'm looking at the balanced data set. It has the sample has about 47 categories of alphabets and numerals. So if you see, it doesn't, the sample does miss images for a few lowercase letters. So it has a total of 113,000 training images and about 19,000 test images. So in this case, each row, right, is a combination of class label, and the next 784 column represents a 28 by 28 pixel image. Size of the training data set is about 218 MB and test data set is about 37 MB. Stages involved. Step 1 would be to visualize and pre-process the data. Second step would be to build, train and evaluate convolutional neural network models. As step 3, so we are considering about 4 models in this project, but when it comes to prediction, as part of step 3, I would be using one of the models to predict to recognize characters from the test data set as well as from one of the images. Step 1, visualizing and data pre-processing. So let me also show you the data, the project structure. So here is the project folder structure. There is a parent structure. Demo folder is the parent folder where you have 2 Python notebook. Part 1 is where you train the models on the MNIST dataset. You also save the output of the model, and part 2 is where you load one of the models. In our case it would be model 3, and we would predict, we would conduct couple of experiments to predict the handwritten characters. And you also have this subfolder dataset. If you go to this, you have the MNIST balanced test dataset and the train dataset in CSV format. A to J is a JPEG image which will be utilized in prediction in the second Python notebook. So let me activate the Anaconda environment. Open the Jupyter notebook. So you have part 1 and part 2. Let's go with part 1. Part 1 is where you do the model training and selection. So I would like to import all these packages. We are considering a category or a total number of labels to be about 47. Epochs can vary, but I'm going with 50 here, but individually for each model epochs might vary. Batch size also can vary, but these are the constants. So here you have few helper methods. One is fetch data frame to fetch the data set as a data frame using pandas. Then you have data frame to array to split the data frame into label and data and return back a numpy array. Image rotate is another utility method. Plot image is where you plot the image in a grid of 3 by 3. This method would plot the graphs for accuracy and loss. So let's go ahead and execute this cell. Then you have about 4 models. I would discuss all the 4 models, but we would be considering model 3 for execution as part of this demo. I'm going to execute this cell. Okay, so pre-processing of data. So here we are loading the data set and we are also trying to look at the data frame. Alright, if you see, the first column happens to be the label, and the next 784 columns comprises of a 28 by 28 pixel image. So let's convert this data frame to array in the required format that we want and delete the data frames. We don't need the data frames anymore. Now let's plot a few images. If you see, it is kind of rotated around the axis. So the this method, image rotate, will help us to rotate it back by 90 degrees and also update the arrays accordingly, the values in the array accordingly. So let's rectify that and also kind of normalize the data and replot the images. We are going to apply that method against the training data as well as the test data and see if the images are correct. Alright, so if you see, this was a H. Now the Q was kind of again upwards, and that's rectified. If you see, this was a V. So now we have, so the corrected train data and the corrected test data has the images in the correct orientation. Next step is to, so we have these labels which we would like to apply one hot encoder. As a final step in the pre-processing stage, we would also like to convert the data set in the required format that the model expects. So that is in the required dimension one is, that is 1, 28, 28, 1. Alright, so that was visualizing and data pre-processing. Next step is to build, train and evaluate the models. So in this case, we have in this project we have considered 4 feed forward convolutional neural net, starting from a simple one to eventually going up to 3 pairs of 2 convolutional layers each. That also includes batch normalization and dropout layer. All our models are at least have 2 convolutional layers, followed by a max pooling layer, which is followed by a flattening layer, and finally a dense layer. fully connected layer. The hidden layers have ReLU activation, while the last layer has a softmax activation. So we will train the model for a maximum of 30 epochs. A few of the models I have increased the epochs to 50, but I have also applied early stopping. And when it comes to early stopping, we are monitoring the loss parameter. Uh, Patience is set to 1, number of epochs with no improvement, after which training will be stopped. Okay, so here is the model 1. This has 2 convolutional layer, 1 max pooling, it just flattens, and then a dense layer and a final dense layer, which with the output of 47, which is in sync with our 47 labels or 47 categories. This is a simple convolutional neural net, and our accuracy for this model was about 84.2. Then we went with model 2. So we are going to decrease the trainable parameters and have used a deeper network with more number of neurons in the fully connected layer. We also incorporated a dropout layer with 50% value as well. The test accuracy went up to 87.1. Our third model is where we introduced batch normalization to model 2 after every hidden layer. Okay, so I'm going to execute model 3 as part of this demo, but just to satisfy my curiosity, I also incorporated the fourth model. This was a model from Kaggle, which was applied on the MNIST digit data set, and they could produce a 99.7% accuracy. I just wanted to apply this on MNIST data set to see how it performs. The model did produce an accuracy of 89.2%, but this was just to satisfy my curiosity, and we will not be using this model 4 going further. Instead, model 3 is what will be utilized to predict. So let's go ahead and so here are all the models. We'll be executing model 3 as part of this demo. Alright, fetch model 3. You will see that these are the layers. Compile. So this has started training. I'll pause the video and I'll come back once it's done. Okay, alright, so our model 3 did run, and here is the final accuracy. It's about 88.7%. Here is the graph. So I have also saved the model, which can be utilized in our second Python book to kind of predict. So one thing here is we had early stopping, and also our optimizer was Adam optimizer with 10 to the power of. So our next step is to predict using model 3. So I have conducted 2 experiments. Experiment 1 is where we predict images from the test dataset itself, and experiment 2 is where I have loaded an image. It has all uppercase and it has A to J, and try to slice each of these letters and try to predict and see what the output is. There are few limitations which will be discussed in the next slide, but for now let's go ahead and load the second Python notebook. Let's import the model that we want, which was saved in the previous notebook. Lookup index method is to just look up the image for a particular label value. Image rotate is the same previous image rotate method which will be applied to the test data set. We are loading the test data set. We need only the test data set in this case. So we are going to randomly pick some 9 images. We are going to predict the same 9 images passing through our model. We will have our model predicted. Looks like it predicts at a very good rate. Maybe one of the characters was not predicted correctly, but others are on the dot. So now in the next experiment, so here is an image, and I have kind of given the width to slice each letter. This is a limitation which will be discussed in the next slide, because the limitation is arises from the fact that this model is trained only on the at the character level and not at the word level. So for A, B, C, D, E, F, G, H, I, J, we got our model predicted A, B, L, D, I, 7, G, I guess this is a T. In case of a H, 4, and it thinks J to be I. So that's about prediction. One thing here is I did not try any lowercase letters because the data set doesn't have lowercase letters for a few sample. Next comes future work and improvements or limitations in this model. So our model did achieve an accuracy of 88.7. This could have been further improved by using a bigger data set or by creating more images through image augmentation techniques. The model was trained only on MNIST character dataset. This is a serious limitation. This will not be able to predict the word, as in we do need a helper method to slice the word into characters and feed those characters into the model, but this could have been further improved by training for words. Along with training the model on MNIST, we should have a mechanism to interact with model that is able to detect words and slice these into characters. Maybe we could have reviewed the IAM handwritten data set for this. That's about it. Thank you so much.